Welcome, everyone. Thank you for joining us for today's webinar. My name is Ksenia, and I'm the Kotlin Marketing Manager for Education at JetBrains. Today, we're presenting Teaching Android Development with Kotlin, the Stanford approach. Our awesome speaker today is Rahul Pandey, Stanford lecturer, Android educator, and Facebook engineer. This webinar is for educators who teach Android and who would like to start teaching Android in Kotlin. But Kotlin is a versatile language. It's used by many universities not only to teach Android, but other computer science subjects as well. So we at the Kotlin team have created a page for educators where you can learn more about Kotlin as a teaching tool. It's kotlinlang.org/education. We're also building an educational community around Kotlin and would love for you to be a part of it. So please check out our page, kotlinlang.org/education, and connect with us. And just a little housekeeping before we get started. If you have any questions during the presentation, please type them into the chat. We'll bring them up during the presentation, and we'll also have some time for the questions at the end. The webinar will be recorded and available to watch later, so please feel free to share the link with your colleagues and other educators who may be interested in learning about teaching Android development with Kotlin. That's it. Now let's get started. Please welcome Rahul.
Awesome. Yeah, thank you, Ksenia, for the intro. Hey, everyone. Thank you for spending some time with us this morning or this evening, wherever you are. I have a pretty brief presentation talking about my experience teaching Android with the Kotlin language and kind of my approach and what lessons I've learned doing that. And then I'm, of course, very happy to connect with people and take questions at the end. So what I want to cover in the next half hour, 35 minutes or so, is a little bit about my background along with the details of the class that I taught. What is my teaching approach and why did I pick that? Some of the benefits of why Kotlin is a really good fit for the class that I taught. And then looking ahead, like what is top of mind for me as I keep teaching this class and keep going on that journey as an educator. So a little bit of a background about myself is I have a full-time day job, which is as an Android engineer at Facebook. So I work on a couple of the different Android apps at Facebook. But outside of my work, what I really spend a lot of time doing and what I really am passionate about is teaching and education. And so for about a year and a half now, I have been publishing a lot of content related to Android and Kotlin on YouTube. And I've actually been teaching in some capacity for about a decade now, starting from when I was actually doing my master's degree and undergrad at Stanford. I was teaching then, and then since I got into industry, I've been teaching in some capacity with organizations or nonprofits since then. And I think the thing about YouTube, which is so amazing, is that it allows me to reach a much broader set of people. So rather than just being constrained to teaching, 20 or 30 people who are geographically close to me in the Bay Area here in California, YouTube has allowed me to reach a whole new population, which is really exciting. And I actually leverage that content in my class. And the reason the YouTube stuff is especially relevant is that was a big part of why I was able to land this teaching opportunity at Stanford. So the iPhone class at Stanford has been taught since like 2012. It's been very, it's been there for a while now. The Android class at Stanford has only really been there since around 2017, I believe. So it's much more recent. And the person who taught it, he did a great job, but he actually ended up leaving Stanford. And so that was where an opportunity came up for me to teach it. And that came as a result of my work on YouTube. So YouTube essentially became a teaching portfolio for me to show people that, hey, I've been teaching Android. You can see some of the quality of what I've taught. And that led me to very easily actually try out teaching this 194A class at Stanford. So I tell everyone who's interested, if you are interested in teaching, there's no barrier, right? Just go on YouTube or pick whatever your favorite platform is and start teaching, writing a blog, creating a video. And you can start teaching without any gatekeeper. So the class I taught at Stanford is called 194A. The link is 194A, cs194a.stanford.edu. Most of the content actually is completely public, so you're welcome to take a look at the slides or the homework if you're interested. But really, the way I think about the class is that it's really focused on building. So this class is elective, which means that it's not a requirement for anyone to graduate from the computer science program. It's completely optional, and people are there because they want to learn Android, which I think is a really good thing. In terms of prerequisites, there's an expectation that you would have taken the introductory computer science classes at Stanford. The very intro class at Stanford is now taught in Python, and the subsequent one is taught in C++. And so the prerequisite for this class is you should have taken that or the equivalent. So if you didn't go to undergrad at Stanford, for example, and you have done a computer science degree from somewhere else, then at least you should have a couple of programming classes under your belt, so you can hit the ground running with Android. There's only one lecture per week, which is about an hour and a half. And I also tried every week to have a session which was more about the broader areas of Android development in industry. For example, things like version control with Git, or how do you do a good code review? What are some navigational tips or shortcuts in Android Studio? Things that really will make you more efficient the deeper you go in Android. One of the really nice things about the class is that, at least the one that I taught, it was a really good mix of students. So you had some students who were, second or third year undergrads who had just taken the core classes of computer science. They were very young in their programming career. You also had students who were had done a computer science degree, had gone out and worked in industry for several years, and then were returning back to Stanford to do a master's degree. And so the level of experience was actually quite different between students. And that actually led to a lot of interesting discussion. And I think it led to a lot of learning that could happen between students. And the structure, just very briefly, you can find more details on the class website. But I talked about the Android ecosystem and the framework as a whole, along with some very brief introduction of Kotlin. Talking about layouts like edit text, seek bar, things like that, common Android views, recycler view, navigation, things like activity and fragment navigation, permissions in the world of Android, networking and using retrofit, and then remote databases like Firebase. So the interesting thing is pretty much no one in the class had taken a Kotlin class before having taken 194A. And in fact, many people had never even heard of Kotlin before joining the class. But I think that I'll talk about this a little bit later. One of the really nice things about Kotlin is that it's quite easy for someone new to the language to pick it up, especially if you have a background in, let's say, Java or Python. And I think students actually ended up finding that Kotlin was one of the most enjoyable aspects of the class, which I'll talk more about near the end of the presentation. So in terms of how I structured the class, one of the things that I really focused on was, given that we only have around 2 hours of synchronous time per week, which is time where I'm actually interacting with students, I took the approach of a flipped classroom. And what that means is the synchronous time that you have every week, that limited amount of time, that's where you really focus on conceptual understanding and interacting with the students, or students interacting with each other. And so I really try and spend that time either doing breakout rooms where students have to do something together, or we go through a Kotlin programming exercise or an Android app together, where I ask for feedback, I solicit help, and I say, okay, here's the problem. Help me figure out the next step. How would I build this app? And then the time at home is to do some of the more mundane stuff, or the things that don't necessarily require that much conceptual understanding. So for example, setting up the assignment scaffolding, like going through and saying, okay, I want an empty project. I want to include this dependency. Things like that are much better done, when you can have a video and you can rewind it, you can pause it, all that stuff can be better done at home. And in fact, this is where my YouTube content came in. For every assignment that I had, I would create a corresponding video walkthrough which reinforced the concepts. So for example, the very first assignment, which I'll show you a screenshot of, was a simple tip calculator where you enter in a number, a base amount, and a tip percentage, and the app will calculate the tip amount and total amount. And so in class, you would talk about the different views in Android and how they're related to each other. And then the video walkthrough would actually show you, here's how you use the different views, and here's how you read input from them. So I think this setup actually worked really well because the time that you have together with the students, you're really focused on understanding and learning from each other or learning from the instructor. And then the time at home is where you can experiment more with Android Studio, copy me in what I'm doing with the assignment, with the video walkthrough, and really learn at your own pace. And so one litmus test that I used is for the in-class period that I had, if I was talking for more than 7 or 8 minutes without being interrupted or without asking for feedback or asking for an answer from a student, that was the point at which I said something went wrong. I always wanted to, every 5 or 7 minutes or so, try and have some sort of engagement with students. And that also led to kind of a more, people felt like they were actually coming to class and they were actually getting some value out of it rather than, having this be something that could have been recorded. So the centerpiece of the class was really focused on building out 3 different projects throughout the 11-week class. The first was a tip calculator, which is really actually quite deliberately stripped down. So there's no internet, there's no data persistence, there's no list, there's no recycler view, right? It's simply a collection of views and you collect user input and you compute something on the fly. Next, we worked with activities and fragments, and we embedded the Google Maps fragment, and you can actually save locations about different places you've been to or where you want to go in this kind of map collection. And the third assignment is building out a Yelp clone. So we go through the concept of creating a Yelp API access token, and then you can actually build your own version of Yelp to look at restaurants or businesses. So the way each assignment is structured is I have a walkthrough video, which allows students to complete a basic working version of the app. And then every student has to complete at least one extension. And then in order to complete the project, you have to submit a GitHub link, and you're going to be assigned a partner. And you should spend around 15 minutes or so giving feedback to your partner about what went well in their project and what were areas where they could have either improved the code or some ideas for improving the functionality or style of the project, along with other thoughts you have. So embedding that notion of giving peer feedback and code review is also kind of a motivation, because if the project is simply going to be graded by some automated process or some instructor, you may not have that much incentive to really try and polish the project. But when you know that someone in the class is going to be looking at this and giving you feedback, I found that that's actually a really powerful motivation for students to kind of go the extra mile. And so what I have linked here, let me click on this really fast, is the assignment handout. So basically, it's a very brief description of the app, which is a tip calculator, which I showed earlier. There's a walkthrough video linked here. And then I also have a bunch of ideas here for extensions. So basically, beyond the basic functionality of the app, you have to do something on your own. So it could be changing the color scheme, which is a very simple extension, or it could be to add more functionality. For example, add a UI element to be able to split the number. For example, being able to split the bill across any number of people, being able to round the total bill up or down, showing currency symbols and persisting that using shared preferences. So there's a lot of different ways that students could extend it. And I basically want to give them some options along with resources that they could very easily follow to implement those. So in order to get credit for the class, it's very, very simple. all you need to do is submit and complete all 3 assignments. There are no quizzes, there are no exams. I really want this class to be focused on building and creating a portfolio of the work that you've done, and having kind of an exam where you have to memorize different concepts. It just doesn't fit well with what I'm trying to achieve. And especially in the world of Android, where things are just changing so rapidly, having an exam or some sort of quiz structure isn't very suitable. And so what I show the students at the beginning of every term is this pie chart, which is actually quite unscientific, but this is my kind of mental model of where do I think is the value from the class. So if you only attend lecture and you don't really do anything else, you'll get about 20% of the value, because you'll basically have a passing familiarity with the terminology of Android, but you won't really have any hands-on practice with Android or Kotlin. If you attend lecture and you also go through the walkthrough videos, you'll get around 40% of the value, because now you'll actually be forced to open up Android Studio, start typing code in, figuring out how to compile it, figure out how to fix the different bugs that you encounter. So you'll get some learning. But really, what you'll see in the 60%, the majority of the value, the majority of the learning in the class actually happens when the training wheels come off and you figure things out on your own. So the extensions are the things like being able to split the tip amount by a certain number of people, or adding a new architecture component into the Android app. That's really where the learning happens. And I want to allow people to explore that and go as deep as they want in that. And so this concept is called low floor, high ceiling, right? Because if you really want to do the bare minimum just to get credit, you could basically do like the blue portion of the pie and the red portion of the pie, and that will actually be sufficient to get credit, right? You don't need to do that much more, because the extension you do could be just changing the color scheme, something very, very simple. And so almost every student can manage that. But if you really want to pursue a career as an Android developer, or even if you don't, but you just want to really explore the framework a lot more, then you have the option to go as far as you want in basically rebuilding the whole project or extending it in a meaningful way. And so this is really a great way to accommodate the different levels of students. Like I mentioned before, you have some students who are actually quite new to programming, and they might just do a simpler extension, but you have some students who have years of industry experience already. And so for them, you want to allow them the freedom to explore and do whatever they want, and go as far as their abilities will take them. And so when I think about kind of the pedagogical approach of the class, I really think about it in terms of I want to be focused on practical, hands-on experience in building Android. I spend very little time focused on the theory about, either memorizing things or even like the performance. I basically want to equip people with enough knowledge that they can actually go out and build things. And of course, some of the things that they build won't be optimal. It won't be performant, but that can be worked on once you actually have something that you can critique and you can improve on. And another big part of the outcome, the learning outcome, is I would like to be able to have students work toward a portfolio. So what that means is the 3 assignments that you build in the class will essentially be a portfolio piece. So you can point to that GitHub link on your resume, or just show people your GitHub profile. And that is really helpful for discussion in interviews. Or if you go on to build your own app, you can basically borrow a lot of the code or a lot of the concepts from the apps that you've already built. And this is also a really powerful motivator for students, because if the assignment or the work they're doing is short-lived and they basically submit it and then it never gets looked at again, there's not as much incentive to keep going after the class. But when you frame the outcome as, here's a portfolio that we're going to build, and you're going to be able to maintain it and show it off to land an internship or a job, months from now, that immediately starts to become a much more powerful motivator to really improve the style of the apps and also the learning, so they can showcase that in their interviews. And also, I want to provide people resources to learn more, right? Because we only have a very limited amount of time in class. So there's no way we can get through everything. But I want to give people the confidence that they know where to look when they do get stuck in the future. There's also a lot of things that we're explicitly not covering in the class. And I think it's important to point this out whenever you're teaching a class, because having a focus on what you're doing and what you're not doing is really important to make sure that, people are spending the time where they should be spending time. So I make it really clear to the students that we're not going to do a deep dive of Android. There's a lot of important topics that we actually simply won't have time to cover. For example, unit testing and the testing pyramid and how you think about what parts of your app to test. We don't talk about that at all, really. App architecture like MVVM and like the advantages of that versus things like MVP or MVC. We don't talk about. We don't talk about gaming at all. Or there's so many other concepts like services or broadcast receivers that we really don't get too much into. And that's a good thing, right? Because you want to focus students on a core knowledge that they can feel good about, and they can learn about these other concepts as they try to embed that into their own apps. And the other thing is I don't make it explicitly a goal to make production-ready apps, which means that, we're not going to be talking about ProGuard and localization and creating an APK or AAB file, which you can immediately put onto Google Play. However, I do point people to resources so that if they do want to go that extra mile and polish their app more and actually create a release bundle, they can actually do that. And I've had a couple students who have gone ahead and published their app on the Play Store, which is really exciting to see. And so taking a step back, when I think about my role as an educator, I really kind of frame it around this mission of how can we accelerate the learning of the student? How can we accelerate your learning? If you think about the world today, especially with COVID, everything can be learned online, right? Like if you have Stack Overflow, you have YouTube, and you have Google. The combination of those three can allow you to pretty much learn everything you could possibly want to learn. And yet we still have so many people who try to learn Android or try to learn any kind of programming or any kind of concept, and they don't get very far. They kind of give up. And so if you think about what is the purpose or the benefit of having a classroom, a cohort-based learning structure, what is that? And I think it boils down to three things. Number one, accountability. Compared to you Googling things or looking tutorials up on YouTube on your own in isolation, one big benefit of having a classroom is that you have accountability. I'm going to impose deadlines where you have to submit an assignment in order to get credit. And having a little bit of that pressure, a little bit of that stress to force you to actually deliver something on time actually goes a very long way in learning, because it forces you to remove all the extraneous details and really focus on what is a deliverable and make sure you complete that on time. A second big benefit of being part of a classroom is peer collaboration. So you're able to, in these live sessions that we have, the lecture period that we have breakout rooms where you can talk to different students about their approach to a particular problem or how they are thinking about extending their project. And so there's definitely a kind of an inspiration aspect where every week I highlight some of the really good submissions or unique submissions to different assignments. And that's really powerful as a way to say, hey, if this person did it, I can do it too. And having that inspiration of peers who have done similarly is super helpful. And then there's also an element here of social pressure, right? Like if you're part of a class, like the last class I taught was around 40 people, and you see these 40 people show up week over week in the Zoom session, then that does actually have a nice effect of you have accountability socially, where if you don't show up the next week, people might start saying, oh, well, how come you didn't show up? Or, what can we do to make sure that you show up the next week? And having that peer pressure is actually really helpful, again, for learning, even if it's uncomfortable. And finally, the third really valuable thing, the third really valuable resource that I think that we provide in terms of a classroom is the support structure. So we use a program called Piazza, which works out really well. It's basically a Q&A forum. It's like a Stack Overflow designed only for our class. And the guidance that I give students is if you're stuck anywhere for more than 20 minutes, then what you should do is stop what you're doing, write down the problem that you've seen or that you're struggling with, what you've tried to do, and what was the outcome when you tried to fix it. and put that information into a question on Piazza, and then it's my job to quickly unblock you. So within 12 hours, I typically try and get back to students within 12 hours with a way for them to try out an alternative path or like hop on a call with them and figure out how to get them unstuck. And not just me, but because Piazza is kind of designed for the whole class, other students who have encountered the same issue can also jump in and provide their commentary. But having that guidance to students about here's when you post for help, here's how you post for help, and here's what information to include when you post for help, that goes a really, really long way in giving students the support they need, that they feel confident that they can actually complete their projects on time. And this is especially important with Android, I think, because I'm sure for anyone here doing Android, there have been so many instances where you spend 4, 5 hours or a whole day working on a bug, which it turns out to be like a one-line issue where you might not have included the right permission, or you didn't hit this single checkbox when you were setting up the project or something, right? There are so many kind of silly things that happen with Android, and having that support structure and that explicit guidance that you should ask for help after 20 minutes and don't spend 3 hours working on something, that goes a really long way in making sure students are on track. So thinking about how do I want students to actually emerge from the class, right? Like you come into the class not knowing very much about Android, not knowing anything about Kotlin. Where do I want you to end up at the end of the 11 or 12 weeks? And I don't expect people to become experts, but one way of framing it is, what is the difference between a novice and an expert? And there are many definitions here, but the way I think about it is that a novice, someone new to a technology or new to a problem space, they don't have the navigational tools to get themselves unstuck. An expert, on the other hand, they have a point of view. They have a way to structure the world around them, structure the information around them, and organize it. And so when they do encounter a new problem, everyone is going to encounter a problem at some point, whether you're a novice or expert. The difference is that the expert, when they encounter that problem, they're able to relate that to their existing worldview and figuring out how to adopt principles or strategies from other problems and apply that to their new problem. And so that is really how I think about learning. I want to provide students who don't really know where they are or like how they get themselves unstuck, provide them a map of here's where they are now, here's where they want to go. So here are the resources that they can use to actually help themselves get unstuck. And this is one of the really big challenges of teaching. And actually one of the really exciting parts about teaching for me is that whenever I interact with a student in office hours or in Piazza, the big thing I try and do is, where are they currently situated? Where are they coming from, right? Try and understand and gauge their understanding. And once you have a sense of that, then you try and figure out how can you connect with the student where they currently are and give them the resources, or maybe ask them a question such that they realize how they can navigate from where they are now to where they want to go. So moving to the discussion of Kotlin, I think for Android classes, you're going to either teach it in Java or Kotlin, right? I think the number of reasons why you should actually teach an Android class in Java is dwindling year over year. So I think a better question compared to like why Kotlin is why not Kotlin, right? Like I think we're getting to the point now where like if you're teaching an Android class, unless you have a really compelling reason to teach it in Java, you really should be teaching it in Kotlin. And there's so many reasons for this, right? Number one, probably the biggest reason is that Google has declared in 2019 that Android is now taking a Kotlin first approach. So what that means is things like code labs or documentation or different libraries, they're going to be developed with Kotlin in mind first. Like for example, Jetpack Compose is a hot new thing. It has support for Kotlin first, right? And so even though many apps today are written in Java, you're seeing that more and more new code is written in Kotlin, And increasingly in the coming years, you're going to find that shift happening more dramatically, not only at the framework level with Android, but also in industry. Across many companies, you're going to see a huge push toward Kotlin. So in order to equip your students to really be prepared for that job market, if they want to end up doing Android, then Kotlin really, really is the way to go. Aside from that, there's also a ton of benefit to Kotlin in terms of it being much easier to ramp up, in terms of a lot less verbosity, and a lot less like code cruft compared to Java. You also have safer code in terms of built-in nullability, and you force the programmer to think a lot about what can be null or mutable compared to a language like Java. And also you have a lot of expressiveness. And I think students very quickly realize all of this, and they actually come to, at the end of the class, the end of quarter reviews I get are usually that they love Kotlin, and that's actually one of the big things that they want to keep going deeper in. That's been my experience with the students in the class I taught. And in order to actually teach Kotlin, what has really worked well for me is relating Kotlin to other programming languages that students may have worked with in the past. So like I mentioned, almost no one in the class has taken a Kotlin class. And in fact, many people have never even heard of Kotlin prior to taking 194A. And so my job is really quickly to show them what is the unique aspects of Kotlin, how is it better or how is it different from other languages that they might have worked with. And so the way I like to do this is actually by doing some sample coding with them. So I'll do a really quick example here with you. So for example, if you have a list of elements, right? What I'll typically do is I'll say, okay, if you wanted to get the last element of the list, which would be 51 here, the way you would do this in the world of Java is probably something like this. You would say mylist.get, and then you would say, I want to get the last index, which is size -1. But if you're a Kotlin developer, the first thing you might improve here is instead of using the .get notation, you can actually replace it with indexing. So you can say mylist, then square bracket notation to get the element at that position, and you do the same thing. And then you can go one step further, and you can say instead of getting the last element by actually computing what is the last index, there's an extension function in Kotlin. So you can briefly talk about the world of extension functions and how those are really magical. But you can say, I want to get the last index of my list. And now this is basically retrieving the last element. And you can go even one step further, right? You can say, I want to get the last element. And there's another extension explicitly designed for that. You can say mylist.last. And so you can see, compared to the Java version, this is just so much more semantically powerful and readable. I can very immediately tell you what this means, and it has much more meaning to me as a Kotlin developer and as just someone new to the code, right? So this kind of example really helps drive home this idea that Kotlin has a ton of benefits over some of the previous languages that students may have worked with. And one thing that I'll point out is that I always have these code snippets in my slides so that, if students are watching, if students are looking at a copy of my slides later on, they have, they can look at it like this. But what I have found is that the retention of the concepts and the code is so much higher if you actually go into IntelliJ or Android Studio. Because I think having this ability to use the autocomplete from the IDE and being able to look at what are the different options available to me on my list. So I have like last index, list iterator, sublist. Being able to poke around and show people how you're actually using the power of the IDE is so critical for learning. So I always try and prefer to do live coding as much as possible in class so that people can actually see me work through different bugs or work through the features of Kotlin with IntelliJ. So looking ahead, in terms of how I think about teaching going forward and what I want to change about the class, one thing that I think is really valuable is that code review aspect and feedback between students. And I think one of the issues that I've been running into is that students are so new to Kotlin, and they're also many of them will do the assignment walkthrough and do a fairly simple extension. And so the actual code review happening so far hasn't been very substantial because largely the code that people write is very much the same. And so I want to try and figure out other ways of providing code review or feedback between students just so to create more interaction. I also think that students have told me repeatedly that they really enjoy using Kotlin, at least compared to Java for students who have Java experience. And so being able to touch on the really nice properties of Kotlin, I think can go a long way in keeping students engaged and wanting to learn more. Right now, I only really teach Kotlin as a way to talk about an Android concept, or like I only talk about Kotlin enough to the degree that is necessary for teaching the Android concept. But I think having a more dedicated lecture on Kotlin and some of the power that the language gives you, I think would be really cool going forward. And I think one other really important thing, which I'm sure many educators in the world have dealt with for the past year and a half or so, or year, is remote versus in-person learning, right? COVID has dramatically changed how education looks and feels for the past year. Both of the classes I've taught at Stanford have been completely remote over Zoom. And that does lead to some challenges, right? Because when you have people who are showing up on Zoom and their video is off and they're completely muted, it's very hard to get feedback. There's no eye contact. If you make a joke, no one laughs, right? So you have these challenges where compared to in-person learning, where you can get that immediate feedback and you have to be much more engaged because you're actually live sitting in the classroom. There are some challenges with remote. And I think over time, the tooling will get better for remote learning, and also we'll figure out best practices. But this is something that, I'm still working on. And I think that it's also still unclear whether the next time I teach a class, it'll be in person or remote. So a lot of this is still up in the air, and it's still kind of a new endeavor to figure out how to optimize both remote and in-person learning. Cool. So that's actually all I had. I'm really happy that many of you spent some time with me this morning. I'd love to connect. I'm pretty active on YouTube, where I publish these Android and Kotlin tutorials. I'm also pretty active on Twitter. But I'm at rpande1234 on Twitter, YouTube, and LinkedIn. So I would love to connect with other educators and talk about different strategies, what worked and what didn't work, and learn from each other. Awesome. So let me stop sharing my screen.
I was muted, sorry. Thanks so much for this great presentation. And I think we have some questions in the chat. Just a reminder to everyone, please be sure to type your questions now so that we can read them and reply. So we have a question about the course that you're teaching. Is it for undergraduate level students or master level, or what type of course CS 194A is?
Yeah, so I'm not prescriptive about what kind of student it's designed for. All I care about is that I want students to have some programming proficiency before joining. Because if you have never programmed before, if you've just taken a very intro class, I think a lot of the speed with which we talk about different concepts might be a little bit overwhelming. So whether you're undergrad or a graduate student, it doesn't actually matter to me, as long as you have enough confidence in programming that you can pick up a new language fairly quickly. So I think if you look at the actual numbers, out of the 45 people enrolled in the class, around half of them were undergrad, typically third or fourth year students, and the other half were master's students.
Right, but the course is open only to Stanford students, right?
Yeah, so yeah, the actual live sessions where we have the interaction and the assignment feedback, like the grading of the assignments, that's only open to Stanford. But all the actual course content is actually available for free. If you go to cs194a.stanford.edu, I've linked all of the slides and the assignment handout. All of that is available if you are interested online.
Yeah, that's great. I dropped this link into the chat, and I'll follow up with all the links. after our presentation. And we also have a question about a certificate, but I guess you have answered it already. So the course is open to Stanford students, so they have their a credit that goes toward their degree, right?
Yeah.
Okay.
So basically, like there's a certain number of units. So we call them units at Stanford, which is the same as the credit. So there's a certain number of units you have to achieve in order to graduate. And so this is like an elective unit that you could get in order to make progress toward your degree.
And we have a question about Kotlin as a backend language of choice. Marian here is developing a mobile app, and they are in need of some light backend project. Do you have any recommendations, Rahul?
Yeah. So actually, I've thought about this a little bit. One of the big things that students want to do is they have an idea for an app and they want to build it on Android, right? That's kind of a natural thing that you would want to do after taking my class. And so the backend of choice that I always recommend is Firebase. And the reason is that there's actually no code to write then, right? Like compared to having to set up a Python or a Node or a Kotlin backend server, if you use something like Firebase, all of that is taken care of for you. And unless you're doing something very kind of unique or custom, Firebase will actually be completely free for you, and it's much easier to set up. So rather than having to learn a whole new framework or a new paradigm on backend programming, just using something like Firebase actually works out really, really well. So I'm not sure if I answered the question there, but like in general, I say don't learn a backend framework. Just if your goal is to ship an Android app, then do the Android part in Kotlin, and then delegate the work of the backend framework and the data layer to something like Firebase is my suggestion.
Okay, thanks. One more question here. Is there a possibility that Google might abandon Kotlin in the future, knowing how Google is inconsistent with their products? So I can answer from our side, from the Kotlin team. So right now, Google has been consistent in promoting Kotlin and more integrating Kotlin into Android development. And right now, it's the preferred language for Android development. And in the educational sphere, Google has created a wonderful page with lots of resources for educators and learners, courses to learn different levels of Android for the beginners, for advanced learners, and even a university curriculum for Android in Kotlin. So there are slides that you can take and adapt to your course, and even the speaker notes, everything you need to start a Kotlin course at your university is there. So they are backing up the language, and their decision is very firm. And they've actually announced that Kotlin is their preferred language in 2019. And since then, we've been working closely together in bringing Android in Kotlin to more educational communities. They have a large program in India where they train Indian educators and universities in Kotlin. So they're very serious about it.
Yeah. I think just one thing I'll add there is that I agree with you. Like I think the risk of Kotlin being deprecated or being moved away by Google is so low right now because number one, they've said it publicly that they want to support Kotlin, and number two, I think if you look at the incentive of Google, they want developer happiness to be high, right? They care about developers being happy and being productive in Android because they want people to build Android apps. And if you look at Kotlin versus Java, it's a no-brainer. Like every person I've talked to wants to develop apps in Kotlin. So I think the risk of Google wanting to move away from Kotlin, given how much people actually enjoy working with it, I think is quite low. So I feel pretty good about sticking with Kotlin as the future of Android for now.
Thanks. And one more question about where can a person learn more about app architecture and factory patterns?
Yeah, that's a good question. I mean, I feel like in the class that I taught, I deliberately don't talk very much about app architecture, just because I want to emphasize building more rather than the correct way of doing things. I think the correct way of doing things changes over time, and people can figure that out once they encounter a problem with their app or like once they have the need to. So I think I don't have a great answer. I think Google actually has some really good documentation about like MVVM architecture and Android app components, like things like Jetpack. And so I'd probably just point you to the Google resources. I think most intro classes won't have too much coverage of those concepts.
Okay, one more question. Do you plan on teaching Kotlin multi-platform?
Yeah, so in general, I'm actually fairly risk averse to teaching like the hot new thing. So I think Kotlin multi-platform is still very, very new, is my understanding. So unless I see it mature and actually start being adopted and picked up in a meaningful way in industry, I don't anticipate teaching that for a while. I think my philosophy is very much try and teach things that are directly applicable to what people are doing. And for things that are a bit more new or experimental, I won't necessarily teach it unless I see things going in that direction.
I can add that I know some courses that already teach Kotlin multi-platform. There are not many, but there are a couple.
Right.
Now, let me check. I think we have answered all of the questions now. So it was great. Thanks, everyone. We really appreciate you being here. Please check out our links. We'll drop them into the chat in a few seconds. And subscribe to this YouTube channel to hear more about our upcoming educational events. It was a pleasure being with you today. Thanks again, Rahul, for this wonderful presentation. Thanks, everyone, for joining us, and we'll see you next time.
Yeah, thank you.